Hi folks, Mr. Long here. I'm going to do a screencast for advanced functions, and what I'm going to do is go through how to use a slope formula right here to figure out where a tangent slope is equal to a certain value. So here's the question right here. At what x value is a tangent slope of f at x, and this is how we're defining f at x, where's a tangent slope equal to 8? And then it says determine the equation of the tangent line. So those are the two things we have to do. So I'm doing this with Desmos, and I put this formula in right here because that's the slope formula, right? So right there, this f at 7.001 minus f at 7 is the rise between x equals 7 and x equals 7.001. So you have to ask yourself, since this is the slope between 7 and x equals 7 and x equals 7.001, it is an AROC, right? It is an average rate of change because it's a slope between 2 points. It's a slope between x equals 7 and 7.001. So the question is that a small enough interval to approximate an IROC? Well, think about that. That triangle is only, the run is only 0.001 wide. So clearly it is very much small enough in terms of width that, or the run, that you can use that as a tangent. So, I've already got the answer there, don't I? So I should probably show you how this would work. So I've already got the correct answer on there. 5. I'll do it at 5 there. So here's the thing. So I'm looking at this picture of a parabola, and I'm wondering where the slope, the tangent slope, is equal to 8. Well, I know it's not over here because the slope is negative all along here, right? So all along here, the tangent slope is negative. And all along there, the tangent slope is negative. And then it's everywhere to the right of the vertex, the tangent slope is positive. So the first one I'm going to try is 5. So do you see how I'm right at 5 now? So what is the tangent slope at 5? Well, I checked it here, and I put in 5.001 and 5. So that's the tangent slope at 5. And I don't know if you can see it very well, but the tangent slope works out to be 4 there. Well, I want the tangent slope to be 8. So if at 5, x equals 5, which is right about there, the tangent slope is only 4. Do I need to go further to the right or to the left? Well, if I'm at x equals 5 and the slope is only 4, the parabola gets steeper as I move to the right and up. So I'm going to have to try something else. So let me try 6 and 6. There, so from 6 to 6.001. So now the tangent slope is 6 at x equals 6. So if you can see that, the tangent slope is 6 there. Well, oh, by the way, just as an aside, notice that I've set this m as the slope, and then I wrote an equation here, y equals mx plus b. So it will automatically take this value of 6 and export it into here. Okay, so that mx is, the slope is going to be m right now. Anyway, I'm still not steep enough. Let's try 7. So at 7, the slope is in fact 8.001. So the slope is, it is the correct steepness now, because I wanted to find a tangent slope that was equal to 8. So the correct answer is x equals 7. So now what I want to do is I want to get a tangent. So now we know a tangent is a straight line. I know the slope has to be equal to 8, which I've already got right there, obviously, because it's mx plus d. Or I can even put, if I want to make it correct, like put a number in it, I know it's 8x, right? The tangent slope is 8. And what I'm going to do now is vary this line here until I get a tangent. And look at that. It looks like, well, that's not quite right. So I want to get a tangent. And the tangent's going to be at x equals 7. So it touches at x equals 7. There we go. So it looks like if I have a y-intercept of -50, that's the tangent, right? You see how if I zoom out, there's the tangent line, right? Right there. And it looks like, oh, the intersection point is at 7, 6. Oh, that's perfect. So there's the point of tangency, 7, 6. So the equation of that line is then 8x minus 50. And that's the equation of the tangent. Okay? So that means the straight line, 8x minus 50, is tangent to x squared minus 6x minus 1. And the point of tangency is x equals 7. Okay? So I'm giving you an idea of how you do that right now. And I'm going to post this online. A link to it, rather, because it's going to be uploaded to YouTube. Okay. Good luck, folks, with your assignment.